Problem 16. Two charged particles are attached to an x-axis. The particle 1 of charge minus 4 10 power minus 7 coulomb is at position x equal to minus 5 centimeter, and particle 2 of charge plus 4 multiply 10 power minus 7 coulomb is at position x equal to 10 centimeter. Midway between these particles, what is their net electric field in vector notation, unit vector notation? So better we can draw the diagram for this question. So here you have two charges. That means the particle 1 takes the value of minus 4 10 power minus 7 coulomb, and particle 2 takes the value of plus 4 multiply 10 power minus 7 coulomb, and both charges, these both charge particles are exactly attached to an x-axis. So first of all, we can draw a line for x-axis, and here we have two charges. That means q1, which is particle 1, and q2, which is particle 2. So these two charged particles are attached to an x-axis. Now the particle 1 is exactly at the location of minus 5 centimeter. So for that, what I am going to do, I can just make an origin. So let's take this is our origin. From the origin to a distance of minus 5 centimeter, the first particle was placed. Clear? So that means this distance. What's the distance? So here I can take x1 distance here is minus 5 centimeter. And then likewise, the second particles are exactly located at a distance of 10 centimeter. So that means from origin O to this distance, your second charge particle was sitting there. So that means this value is x2 equal to 10 centimeter. Now we have these two charges, and also they mentioned the value of the charges. What's the value of the first charge? The first charge value is minus 4 multiply 10 power minus 7 coulomb, and then the second charge value here is plus 4 multiply 10 power minus 7 coulomb. So one is positive, one is negative. That means here the first charge q1 is negative and the second charge q2 is positive. Now what they ask, we have to find its electric field. That means the net electric field in the midpoint between these particles. So we have to find the midpoint. So first of all, what we have to do, let's take the total distance between the two particles. What's the total distance? Here is x1 equal to 5 centimeter. Here we have 10 centimeter. That means if you take the distance between q1 and q2, the total distance here is 15 centimeter. Am I right? So let's take the magnitude of this value. So the total distance is 15 centimeter. Now we have to take, because they ask you to calculate the net electric field in the midway between these two particles. That means what is the half of this 15 centimeter? So the half of the distance is 7.5. Am I right? So that means from the charge particles to this distance is 7.5 centimeter, and likewise exactly from this distance to the second charge particle is again 7.5 centimeter. So that means from the midpoint to the first charge, the value of the distance is 7.5 centimeter. The same value of 7.5 centimeter is for second charge. So that means we have to find in this place what is the electric field, and also we have to find its direction, because we have to give the answer in terms of unit vector notation. So we will give this answer later. First of all, we can start solving the problem. What's the formula we studied for this question? We studied the electric field due to a point charge. The equation for the point charge electric field calculation is E equal to K Q over R square. So this is the formula, right? So now I am going to use this formula. So here the R is exactly, here R is the distance from the midpoint to the first charge, and here the distance from the midpoint to the second charge is also R. So that means for two charges, the midpoint here is 7.5 centimeter. So let's take this 7.5 centimeter is X value. So that means the X value is 7.5 centimeter for both charges midpoint. So the distance between the two charges midpoint is here is 7.5 centimeter. So I take this value as X. So that means if you want to write the equation in terms of X, how we can write? We can write this formula as E equal to K Q over X square. Clear? But we have to use this formula for two charges. So in this place, we are going to find the electric field. So what we have to do, we have to substitute these values in this formula. So the net electric field equal to K Q1 over x square plus K Q2 over x square, because two charges we are going to find the electric field, but this is the magnitude of the charge. Am I right? So this is our magnitude value. Now we have to substitute the value here. So the value of K, so let's take the common term outside, or you can substitute the value exactly inside. So if you substitute the value here, which is 8.99 multiplied 10 power 9, the value for K, multiplied by the magnitude of the first charge, because here we have the first charge value is -4. So I can take the magnitude. So -4 multiplied 10 power -7 coulomb divided by the x value here is 7.5 centimeters. So we have to convert it to meter. So 7.5 multiplied 10 power -2 the whole square. Likewise, I have to substitute the value for the second charge, which is 8.99 multiplied 10 power -9 multiplied by the magnitude of the second charge, which is 4 multiply 10 power -7 divided by the value of x again here is 7.5 multiply 10 power -2 the whole square. Now I have to calculate to find the net electric field. So once we find the answer, let's see what's the direction. So that I have to substitute the value 8.99 multiply 10 power 9 multiply 4, because the magnitude of the -4, 10 power -7 is +4, right? So 4 multiply 10 power -7 divided by 7.5 multiply 10 power -2 square. So here I got the answer as 6.39 multiply 10 power +5, and the unit for the electric field is Newton per coulomb, and its direction is x-axis. So in terms of unit vector notation, I have to mention I cap. Likewise here, the same, because the values are same, so you'll get one more 6.39 multiply 10 power 5. The unit for electric field is Newton per coulomb, and this is also in x-axis, so I have to write this. Now I have to add these two values. So 6.39 plus 6.39, I got the answer 6.39 plus 6.39. Here I got the answer as 12.78. So 12.78 multiply, because we have to include the power also, because in both values we have the power 10 to the power of 5. So 10 power 5 Newton per coulomb I cap. Now we have to find the sign, because the electric field is a vector quantity, right? Okay, let's retake. When you take the test charge, when you bring the test charge near to the positive charge, what will happen? It will repel, because the test charge is also positive and here point charge is also positive. So what will happen? Your net electric field due to the second charge will be in this direction, right? So this is our E2 value. Why this direction? Because my test charge is also negative and so test charge is positive and this Q2 is positive, so it will be repelled. Likewise, I have to find the electric field for the first charge. Test charge is positive and the first charge, that means Q1 is negative, so it will be attract. So again you will get E1 direction in the same direction, right? So that means both E1 and E2, the direction of electric field due to the first charge is also in the negative direction. The electric field due to the second charge is also in the negative direction. So here we have to mention the sign as negative. Clear? So this is our final answer. So that means the net electric field due to these two charges, we got the answer as -12.78 multiplied 10 power 5 Newton per coulomb I cap. So this is the answer for this question. Thank you.